Welcome back, students. For the last session, that is session number 11 on introduction and analysis of plane trusses. So in the last session, we have applied the concept of influence lines to find the axial forces in a given truss by using unknown quantities, okay, in terms of A and H and theta, like that. But in this session, we will take up an exact numerical problem, okay. So the problem is to draw the influence lines for the forces in members EF, BF and BC. Okay. So the given truss is this one. So we have to find the force in member EF, BF and BC. So one top chord, one diagonal member and a bottom chord. Okay. So the top chord is EF, diagonal member is BF and the bottom chord is BC. Okay. So as usual, write the ILD for the reactions at A and B. So since it is divided into three equal parts, three spans at 2 meter intervals, so each span will be equal to 1/3 and 1/3. Okay, so CD will be 1/3, BC will be 1/3. So the ordinates will be 1/3, 2/3 and 1. Okay. Similarly, if you draw the ILD for RB, ordinate at B will be 1/3 and at C will be 2/3. Okay. So and this is the bending moment at any point on a beam, which is equal to AB by L. Okay. So first let us draw the influence line diagram for the top chord, that is EF. So this is the given problem. Okay. So EF member is this one. So we have to consider a section in such a way that it cuts the required member. So all the three members will be cutting through this section 1 only, EF, BF and BC. So we'll continue with the same section. Okay. So consider section 1-1. In that, let us consider the first case when the unit load is in between AB. When the unit load is in between AB. Okay. So there will be two cases. Before this section, one case, and after this section there will be one more case, and between the panel of this section. Okay, like this. Okay, so first section is when the unit load is in between AB. So this is the unit load. Let us assume this is the unit load. Okay, so as the unit load is in the left section, we will consider the right section for applying equilibrium conditions. So this is the right section. Height of the truss is 1.5 meter and each span is 2 meters. Okay, each segment is of 2 meters length. So we have to find force in member EF. So we have to eliminate these two members. So that can be done by taking moment about B. Okay, as these two members are meeting at joint B. So apply sigma MB is equal to 0. So that implies force in member EF into H. H is nothing but 1.5 meter and this RB into this distance, that is 4 meters. Okay. So that will be minus EF. This is inducing anticlockwise moment. EF about B anticlockwise and RB, that is also anticlockwise. So minus EF into 1.5 minus RB into 4 meter. So that is equal to 0. So that gives force in member EF is equal to minus 2.67 times of RB. Minus 2.67 RB. Okay. So let us apply the boundary conditions. When the unit load is at A, when it is at A, RB will be equal to 0. Therefore, force in member EF will be 0. Next, when the unit load is at B, okay, RB will be 1 by 3, not minus 1 by 3, it should be 1 by 3. Okay. So if you substitute it, force in member EF will be equal to minus 2.67 into 1 by 3, that will be equal to minus 0.89. Okay. So let us draw the variation. Draw the baseline first. It varies from 0 to minus 0.89. Minus means draw it below the baseline. Draw it below the baseline for an ordinate of 0.89. Okay. Next, when the unit load is between CD, so this the next segment when the unit is in the CD section. Okay, so let us consider the unit load in that part. Okay, so as unit load is in the right section, let us consider the left part for the application of equilibrium conditions. Okay. Same thing, apply sigma mb is equal to 0 so that we can eliminate these two and we can have only force in member EF. So force in member EF, this is inducing clockwise moment about B, therefore for EF into height is 1.5 and RA into 2 meter, that is also inducing clockwise moment about B. So FEF into 1.5 plus RA into 2, that is equal to 0. Therefore force in member EF is equal to minus 1.33 RA. Minus 1.33 RA. Let us apply the boundary conditions. When the unit load is at C, okay, RA value will be equal to 1 by 3. RA value will be equal to 1 by 3. Therefore, force in member EF is equal to minus 1.33 into 1 by 3, that will be equal to minus 0.44. And when the unit load is at D, RA will be equal to 0. Therefore, force in member EF is equal to 0. So, let us plot this variation. It from C to D, it ranges from minus 0.44 to 0. So, this one minus 0.44 to 0. This ordinate is minus 0.44. It ranges to 0. And now, in the midsection, that is the panel where the section passes through, you just join with the straight line. Okay, linear variation from B to C or from C to B. Okay. So as the total ordinates are below the baseline, the entire ILD is negative. Okay. So this is the influence line diagram for the top chord EF. Okay. Next, we'll take up the diagonal member BF. So passes section, same section 1-1. Consider it when the unit load is in between AB. Consider the right part. Okay. So we have to find force in member BF. Okay. We'll resolve this inclined force along x and y components. So x component is FBF cos theta and y component is FBF sin theta. Okay. So we have to avoid this FBC. Therefore, we'll apply sigma Fy. Okay, so what is the value of theta? If this is theta, opposite is 1.5 and adjacent is 2 meter. Therefore, 1.5 by 2 that is equal to tan theta. Hence, theta is equal to 36.87 degrees. Okay. Now, we will apply sigma Fy is equal to 0. So, which implies plus RB minus FBF sin 36.87 is equal to 0. So, therefore, force in member BF is equal to plus 1.67 times of RB. Okay, 1.67 times of RB. Apply the boundary conditions. When the unit load is at A, RB value will be equal to 0. Therefore, force in member BF is 0. Next, when the unit load is at B, RB will be equal to 1 by 3, that is equal to 1.67 into 1 by 3, that will be equal to 0.56. Force in member BF is equal to 0.56. So let us draw the variation now. Draw the baseline. It ranges from 0 to 0.56. Positive means you have to draw it upward. Okay, so this ordinate is 0.56 and it is positive. Okay. Next case is when the unit load is between C and D. So the second case is the unit load is in between C and D. Okay. So we have to consider the left part as load is in the right part. Okay. This is the free body diagram of the left part. Again, resolve this inclined force along x and y directions. Okay. Apply sigma Fy is equal to 0, which implies RA plus FBF sin 36.87 degrees is equal to 0. Therefore, FBF is equal to minus 1.67 times of RA. Okay. So, at x is equal to, when the unit load is at C, okay, when the unit load is at C, RA will be equal to 1 by 3 because it ranges from 0 to 1. 1 will be at A. Okay. So, this ordinate will be 1 by 3. Therefore, minus 1.67 into 1 by 3, that will be equal to minus 0.56. So, force in member BF will be equal to minus 0.56. And when the unit load is at D, RA will be equal to 0. Therefore, force in member BF is equal to 0. So, let us plot this variation between C and D. it varies from minus 0.56 to 0. So minus means draw it below the baseline for an ordinate of 0.56 negative. Okay. So now in between BC panel or BC segment, you just join these two endpoints from positive to negative. So this is how you should draw the influence line diagram for a diagonal member BF. Okay, so this is the influence line diagram for BF. Next we will take up the bottom chord BC. Consider section 1-1. Okay, assume the loading is in between AB panel. Okay, consider the right part. Okay, so we have to find force in member BC. So we have to avoid these two, means apply moment about F and equate it to 0. So take sigma MF is equal to 0. So that implies, so this BC is inducing clockwise moment about F. Therefore, FBC into height is 1.5 and RB is inducing anticlockwise moment about F. Therefore, minus RB into 2 meter, that is equal to 0. Therefore, force in member BC is equal to 1.33 times of RB. Okay. Now you apply the boundary condition, that is when the unit load is at A, RB will be equal to 0. Therefore, force in member BC is equal to 0. Next, when the unit load is at B, RB is equal to 1 by 3. Therefore, force in member BC is equal to 1.33 into 1 by 3, that is equal to 0.44. Let us draw the variation. This is the baseline. It varies from 0 to 0.44 positive. Okay. So, this ordinate is 0.44. Next, when the load is in between CD panel, consider the left part. This is the FBD of the left part. Okay. Same thing. Apply sigma B. We have to find force in member BC. Okay. So apply it at F only. Okay. So then minus FBC. So moment of these two about F will be 0. So minus, it is inducing anticlockwise moment about F. So minus FBC into height is 1.5 and then RA, this is inducing clockwise moment about F. Therefore, RA into F is at this position. So perpendicular distance is 4 meter. RA into 4, that is equal to 0. So if you simplify, FBC is equal to 2.67 times of RA. Okay. Now you apply the boundary condition, that is when the unit load is at C, RA is equal to 1 by 3. Therefore, 2.67 into 1 by 3, that will be equal to 0.89. Force in member BC is equal to 0.89. And at D, RA is equal to 0. Therefore, force in member BC will be equal to 0. So, now we will plot the variation from 0.89 to 0, positive. So, this ordinate is 0.89 to 0. This is 0.89. So, when the loading is in between BC, so just join these 2 points with the linear line. Okay. So, this is, as the ordinates are positive, so this member will be under tension. Okay. So, this member will be under tension, whereas the top chord is under compression, and this diagonal member is having both types, experiences both types of forces depending upon the position of the loading. Okay. So, this is the influence line diagram for the bottom chord BC. Okay. So, while solving a given problem, you have to draw, as we have drawn in case of shear force and bending moment, we will be drawing the given loading diagram first, then shear force, then bending moment, and then deflected shape, like that. Okay. So, here also while drawing the influence line diagram, you have to draw one below the other, like this. So, this is the given truss. This is the influence line diagram for the top chord EF, and this is the influence line diagram for the diagonal member BF, and this is the influence line diagram for the bottom chord BC. Okay. So, you have to write like this, one by one below the other. For any number of members, you have to write one below the other. Okay. So, that is for today's session and for this module 1. Okay. So, wherein we have learnt about the type definition of a structure, types of forms of a structure. Okay. And then conditions of equilibrium, compatibility conditions, and then statically determinate and indeterminate structures, degrees of freedom, kinematically determinate and indeterminate structures, how to find the degree of static as well as kinematic indeterminacies, and we have solved some problems on that as well. Okay, and we have taken up a entirely different concept of influence lines, and we have applied it to find the reaction, shear force and bending moment for a simply supported beam. Using that, those standard diagrams of influence line diagram for reaction, shear force and bending moment, we have analyzed a numerical problem, and as well as we have applied it to the analysis of member forces of a given truss. Okay, so that is the outcome of outlook of this module 1. Okay, so in the next module will the same thing, the influence line concept will be extended in the next module as well, but we'll be having a moving load. Okay, so we'll be applying for a series of point loads, UDL longer than the span, shorter than the span. Okay, we'll be applying it to the numerical problems in the next module. So that's it for the module 1 and for this session. Thank you.